Hi, in this video this series of videos we're going to be working through a GCSE paper. Please do stop the video, have a go at each of the questions, then compare your solutions. Each of the videos is going to be about 20-30 minutes or so. It should give you about an hour's worth of fairly focused revision. If you're not sure about anything, always add a comment. I'll come back to you and I'll look forward to seeing you inside the video.
Hi, so this is the second video where we're looking at the November 2019 higher tier maths paper for Edexcel. In the previous video we completed through to question number 9, so in this video we're going to complete through from question 10 onwards. Okay, so here we are at question number 10 and we're being asked to plot a cumulative frequency graph. Now it's going to be a little bit tricky on the video, but hopefully you'll be able to see that what I'm actually going to do is plot 5 to 40, 25 to 60, 35 to 80, 38 to 100 and 40 to 120. And that will give me the ability on this grid to be able to plot a very nice cumulative frequency graph that will look something like this. Is 40 to 5, okay, and I've got then 60 to 25, so that's going to be here, and then I've got 80 to 35, which is going to be there, and then I've got 100 to that one is going to be there, okay, and then I've got 120 to 40, which is there, and what you'll actually get out of this is a nice smooth curve that looks something like that. Okay, now the final part of the question is going to be part B and C, and the first part of it, which is on page 2 of the actual question paper, which you can download from 3 Minute Maths, asks you to work out the interquartile range. Well, there are 40 people represented on the graph, so the interquartile range is the mid 25%. So if I look at the 10th person along here, that means that the 10th person, which is 25%, is at 46, so that's going to be the lower quartile, and then the upper quartile is going to be the 30th person along here, and I can just take the reading directly from the graph. And I do appreciate that it's not exactly correct, but there is a variation, a range here that you can use, so therefore I'm just going to write this actually on the side of the graph here, and I'm going to put the interquartile range, and that's going to be equal to 68 take away 46, which is going to give me 22 minutes, and that would be the answer to part B of this particular question, which is on the next page. Okay, part C asks us to work out of the 40 people that are chosen random, probability that the puzzle will be completed between 50 and 90 minutes. Okay, so let's look at 50 minutes. So all I'm going to do is I'm going to take my 50 minutes from here. This is 50 minutes, and that person would be roughly about the 13th person. I appreciate I'm doing this fairly quick at the moment, but hopefully you'll get the idea. And then I'm looking at the 90 minutes to complete the puzzle, and that's going to be all the way over here, so that's going to be this one here, 90 minutes, okay. And again, if I take that across, it's a little bit tricky on the video, but hopefully you can see that's going to be 37. So the probability really is going to be the difference between 37 people and 13 people, and therefore that's going to be 24 people. And that's out of 40 people. So 24 out of 40 is going to be the answer to part C of this particular question. Okay, let's move on then to question number 11. I'm going to skip, and you can see there that's the second page that we've just completed. So let's move on then to question number 11. There are P counters in the bag. 12 of the counters are yellow. Shafiq takes at random 30 counters from the bag and 5 of these. So basically what we're saying is that 12 out of the amount of counters, which is P, is equal to 5 over 30. And then really it's just a case of finding the value of p. But what I'm going to do, just to make my maths a little bit easier, I'm actually going to reduce that 5 over 30 to 12 over p equals 1 over 6. It just makes my life a lot easier, because then I can cross multiply. So what I actually get is going to be 72 equals 1p. Okay, and therefore p must equal 72, so the value of p in this particular case would be 72. Okay, let's move on then to question number 12, where we are looking at Spencer's method for making Q the subject of the formula, and what's the problem with it. These types of questions seem to be becoming a bit more popular with GCSE, where you're being asked to critique. The problem he's got here is, although he's multiplied one side by 2, which is perfectly fine, he's not multiplied all the sides or all the other terms by 2. So he should multiply, if we put all terms by 2, okay, and then just for the sake of this particular video, I'm going to write 2t equals q plus 10, and that's his particular problem. It should have been 10. Okay, let's move on to the next one, which is a bit of an awkward one, really. It's being asked to write this as a single fraction in its simplest form. I'm not entirely sure it's in its simplest form, but you know, we'll work through it, because basically when we add fractions, we've got to make sure the denominator is the same. So therefore, the first fraction, I've got 5 over x plus 1. Well, I need to multiply that by 3x, top and bottom, in order to make the denominator the same as the next one, okay? Because then I'm going to have 2 multiplied by x plus 1, and that's all divided by x plus 1 multiplied by 3x. So what I've done there is I've made those denominators exactly the same. And then really it's just a case of making that look a little bit tidier. So if we look at the first fraction, I'm going to get 15x, and I'm going to divide that by 3x squared plus 3x, and then I'm going to add that to 2x plus 2, because I've got to multiply out each of the terms, and that's again divided by 3x squared plus 3x. Okay, when I bring this whole lot together, I'm going to get 17x plus 2, all divided by 3x squared plus 3x. If I really want to, I could actually write that as a factorisation at the bottom, so it's 17x plus 2, all divided by, take out 3x, and I've got x plus 1. Okay, so a little bit of an untidy question, really. It doesn't sort of look as if it's the simplest form particularly. Okay, let's move on then to part B of this particular question, where I've got x plus 2 squared plus 3 times x plus y. So let's just have a look at what that actually is. So I've got x plus y multiplied by x plus y, and I'm going to add that to 3 times x plus y. So I'm hopeful that it kind of makes sense to you that really what we've got is a common factor of x plus y. So I can take that out, and then I'm going to be multiplying that by x plus y and then plus 3, and that actually would be the answer to that particular question. Hopefully that's okay. If you're not sure about any of these, please do let me know in the comments, and I will always put a playlist or add a video for you that might be helpful. Okay, so let's move on then to diagram shows a right angle triangle, and it says the area of the triangle work out length of the shortest side. Okay, so how do we work out the area of a triangle? Well, the way we do that is we write a half base times height equals the area. Okay, so, or you might want to write base times height divided by 2, and that's perfectly fine. So let's put a little bit of some of the information that we've got. I'm going to write that as a half, and the base is going to be x minus 2, multiplied by the height, which is going to be x plus 4, and I'm going to close those big brackets off, and that's going to equal 27.5. And then really it's just a case of solving this, finding the values of x. Well, the first thing I need to do is I need to get rid of the half. So therefore, if I multiply both sides by 2, what I actually end up with is going to be x minus 2 multiplied by x plus 4, and that's on the left hand side, gets rid of the half, and on the right hand side I've got 27.5 multiplied by 2 is 55. Okay, so let's expand the brackets. I'm going to get x squared plus 2x minus 8. Just be careful of those positives and negatives. That equals 55. And then in order to factorize this, I need to make sure it equals to 0. So therefore, I'm going to write that as x squared plus 2x and minus 8 minus 55. Don't forget, I'm going to bring this over from the right-hand side. It's going to give me minus 63 equals 0. And that's excellent because that will actually factorize for x minus 7 multiplied by x plus 8, because two factors, I beg your pardon, x plus 9, I'm so sorry, okay, x plus 9, and that equals 0. And the reason that is because two numbers that multiply to make minus 63 and add to make plus 2 are minus 7 and plus 9. Okay, so therefore I've got my two values of x. X is going to equal, x minus 7 equals 0, so therefore x must equal 7, or x plus 9 equals 0, so therefore x must equal minus 9. Now my problem is that I can't have a value of minus 9. It has to be a value of 7. So therefore if I go back to my triangle, this short side over here is going to be 7 minus 2, which is equal to 5, and the slightly longer side is 7 plus 4, which is going to equal to 11. So therefore the shortest side in this particular question will be equal to 5. Shortest side equals 5, and that would be the answer to that particular question. Okay, let's move on then to the next question, which is going to be number 15, and it's a recurring decimals to fractions. And one of these questions can be a little bit tricky, but the technique is that I would always sort of start by saying x equals 0.41818 dot 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 dot. Okay, I'm going to say that 10x equals 4. Oops, I just put that on the wrong side there. Okay, is equal to 4.18181 8 and so on. And I've also got, if I want, I can do, I think what I'm going to do is I'm going to do 1000x, because if I do 1000x, what I end up with is 418, and then you can see after the decimal point I've got 1818 and so on, which is exactly the same as this value of 10x. So therefore it gives me the ability to subtract one from the other and lose the recurring side of it, because if I write 1000x equals 418.181818 so on, and then I take away the value of 10x, what I actually get is going to be the ability to lose all of this which is after the decimal point. So therefore I end up with 990x equals 414. Okay, and then really it's just a case of writing or dividing both sides by 990. That's going to give me x equals 414 divided by 990, which probably is sufficient for this particular question because it doesn't ask for it in its simplest form. If you wanted to write it in its simplest form, it would be 23 over 55, and you'd need to kind of divide through by 2s and 3s and what have you to get to that particular point. But either way, that would be the answer to that particular question. Okay, let's have a look at 16a. And 16a is rationalise the denominator. Basically all that means is make the bottom number a whole number. So what I'm going to do is I'm going to take my 22 over root 11 and I'm going to multiply the bottom by root 11, the denominator, but therefore I have to multiply the top by root 11 as well. So what I actually end up with is 22 root 11 divided by root 11 times root 11 is going to be a value of 11 itself, because it's 121. The square root of 121 is 11. Okay, so therefore I can just simplify this a little bit and end up with 2 root 11, which is the answer to that particular question. Okay, let's have a look at part B. Now it can be written in that format, but the way I'm going to do that is I need to take my root 3 over 2 root 3 minus 1, but I need to multiply that by 2 root 3 plus 1, because what happens is then is I lose the surd values. However, I've got to multiply the top by 2 root 3 plus 1 as well. Okay, so let's look at that when we kind of work it all out. I'm going to work out the denominator first. So I'm going to say 2 root 3 times 2 root 3 is going to be 2 times root 9, which is exactly the same as saying 4 times 3. It's actually, I beg your pardon, it's going to be 4 times root 9, so therefore it's going to be 4 times 3. And then, so I've dealt with that, and then I need to deal with this second one. That's going to give me plus 2 root 3, and then I've got minus 2 root 3, and then finally I've got minus 1 times plus 1 is going to be minus 1. So that deals with the bottom for the moment. The top I'm going to multiply out. I've got root 3 times 2 root 3. Well, again, that's going to give me 2, but it's multiplied by the square root of 9, which is actually 3. Okay, and then finally I've got root 3 times 1 is going to be plus root 3. Okay, so let's tidy it up a little bit. So the top is going to become 6 plus root 3. The bottom is going to become effectively 4 times 3 is 12. Plus 2 root 3 minus 2 root 3 cancels each other out, and then I'm going to get minus 1 at the end. So my final answer will be 6 plus root 3 all divided by 11, and that would be the answer to this particular question. Okay, so I'm very aware that time is moving on a little bit here. I think what we'll do is we'll just do the final question itself, which is on mathematically similar shapes. Now, if you're not sure about any of these, please do let me know in the comments. I do have other worksheets that you can have a look at. Okay, so this one isn't necessarily as tricky as it makes out, because we've been given the area ratios. Okay, so that's basically the area scale factor. So if I put this here, the area scale factor is going to be 4 to 9. Okay, now therefore it means the length scale factor is going to equal the square root of 4 to the square root of 9, which is actually going to be 2 to 3. Okay, that's an important bit of this. It can also use the volume scale factor, which is going to equal to 2 cubed to 3 cubed, which is going to give us 8 to 27. Okay, so therefore what we're actually saying is that if he pours all the water from container A into container B, every time he's pouring it in, what he's actually pouring in is going to be 27 divided by 8. It's how many 8s, how many lots of 8 are there in 27. So you imagine it's 27 cubic centimeters divided by 8 cubic centimeters, and effectively that's how this particular problem is being worked out. So therefore we're going to say that the number of times is going to be equal to 27 divided by 8, and that's going to be 3 and 3/8. Okay, so therefore here Tyler will fill 4 times Okay, and if you want to, you can put something like not all of cylinder A on the 4th attempt. Okay, or 4th time. And that would be perfectly fine for that particular question. Okay, so we're going to stop the video there. It is the higher paper, so things are a little bit more challenging towards the end of the paper. However, I hope it's been useful to you. Please do let me know in the comments, and I look forward to seeing you in the next video, where we're going to start with question number 18.